SQL initially, when it was launched, like almost 40 years ago, it was optimized for storage, meaning that storage was expensive then, but it is not now. Right? And that allows us to think differently. So that's the reason why we are kind of having the debate between which works best, right? But then again, for normalize or queries, or if you are looking for relational design, SQL works best, right? But when it comes to looking at partition-based storage, or you're looking at a schema design, which is very specific to a certain partition key, you may look at NoSQL. And here, traditional SQL kind of has, generally speaking, it has the ability to scale vertically, right? And in this case, NoSQL can go horizontally. So there are ways that you can have a database which can scale horizontally. And if you remember the typical CAP theorem and Pi theorem, that are kind of identifying which works best for you: consistency, availability, or partition tolerance, right? So this is like the best way to get around that. And this is a whole family of databases. Okay, I won't expect you to look at it and remember all the names, but we will look at it one by one. Okay, and that's quite a lot if you look at it, right? So let's look at the first one. We have a service which is called as RDS, right? And for that, we will design it as per relational. So we know this. This is not something which is new to us. So we have data which is in tables, tabular format. You can have it in primary key, foreign key, so on and so forth. And you are able to simply have it on your database, right? So you get extremely high accuracy and consistency. And in this, we have got what is called as a managed service, which is relational database service, Amazon RDS. Okay, this gives you different types of engines as flavors. You can choose what works best for your applications, and then it does the heavy lifting for you, which means that installation of the software, patching, upgrade, all of those things are automated. So for you as a customer, you simply bring your data, you simply point your applications to the RDS technically endpoint of any of these databases, and you're good to go. So availability, scalability, patching, upgrade, these things are taken care by the service itself, which is RDS. So all of these features apply to any of the engines that you choose, right? So this is the first one. And because a lot of customers also used to complain that, okay, you know what, we have a lot of DBAs, but they spend a lot of time in just the admin tasks. They just are keeping, doing the same job over and over, backup, recovery, refresh, so on and so forth. How can we automate it? So Amazon thought, okay, this is an option. You have a managed service, which addresses majority of the customers' problems, and you have RDS there. Now, customers also reached out and said that, you know what, we are running some license-based databases, and we want to get free of the licensing. We don't want to pay for, so in a way, Aurora is an answer to the question, which is, how can I get enterprise-grade performance with open source database? Best of both worlds, right? So that allows customers to choose either between Postgres or MySQL, and you can create your own cluster, Aurora cluster, and you get enterprise-grade performance on open source. So this basically kind of, it's most of 1/10 of the cost that you might end up paying per se. Going a little deep onto the Aurora architecture. So this is more where Aurora kind of thought differently, wherein you are decoupling the compute from the storage. So the storage is what is called as cluster volume, and that allows you, or other, Aurora kind of replicates the data up to 6 times. Okay, so you have extremely high durability and availability of your data. That's the storage layer. On top of it, if you need to have multiple compute, which means that you have one writer and multiple readers, so depending on the way you want to scale your application, you can pretty much do that. That gives you or the customers the flexibility to ensure that you are able to scale your applications the way you need. Going further, we also introduced Babelfish for Aurora Postgres. Now, we had also a ton of customers who said, hey, you know what, we are using SQL Server, but we want to move to open source, but is it possible to do it without any application or code change? So Babelfish is one of the features, or rather one of the services which have been launched that is open source. So it's done by AWS team, and you can have a look at the source code, for example. So basically you are able to, Babelfish understands the T-SQL dialect. Okay, so that ways you can have Aurora in the back end, and you can still have the SQL Server-based applications running in the front end. So you still get the freedom of getting away from your licensing, for example. Then we had customers saying that, hey, you know what? We want to have multiple ways of, number one, running the database, and we also want to make sure that we are not paying for it. Okay, meaning we only pay for the ones that we use. So, for example, if I have a query, I'm running some analytical report only once in the weekend, okay? And that takes, let's say, 5 hours. Now, if I have to solve this problem, I don't want to keep my database running 24/7 just for that one report. This is where Aurora Serverless comes in. Now, this is your answer to ensure that you are able to scale your applications automatically depending on the job or depending on the need. Now, it is kind of granular because you are actually able to get the advantage of pay per use, pricing per second. So if you are able to have optimized query, I know it's difficult at times, but if you are able to run optimized queries and get the data from Aurora Serverless, you only pay for the time that is running. That's again one more level up for you for any kind of spiky workloads. If you just wanted to run it for a short period of time, Serverless works best for you, right? So we also have one more feature within Aurora Global Database, Aurora, which is called as Global Database. Now, to help you understand, I've just put an image here. So I'll also show a demo in a moment about this. So you have got one region, let's say London, as primary, which is read-write. And you want to make sure that you have branch offices. Let's say it's a bank, and bank has multiple branches across the globe, and you want to ensure that you are having millisecond latency. As soon as you write something in primary, let's say in London, it has to be replicated in Singapore, in US, in UK, something like that, right? So in this case, it becomes all the more easy for you to maintain one primary and have multiple reads or read instances across the globe. And the beauty of this is you can fail over from one to another. So we'll look at that. Now, which customers are using all of these services? So we have Expedia, who's using a combination of multiple services. We have got Aurora. We have got also Elasticache. We'll come to Elasticache in a moment, but it's like multiple customers leveraging the power of different services. So I feel like it's kind of something which is related to the D&D characters. So I put those on the slide there. So it's like each one has its own power and each one has a different control, right? So it's like you need to get all together. Going further, we have got key value pairs, right? So we have the service which is called as DynamoDB. And when you say DynamoDB, it allows you to have key value data at scale. Now, if you look at multiple mobile applications, most of them are powered by DynamoDB, which are AWS customers, and that simply makes sure that you are able to have your get and put, which is reads and writes. So not a typical SQL query, you do an API call against DynamoDB, and it'll just perform at scale. It doesn't matter. So the beauty of this is that you can have actually serverless architecture, okay, which means that you don't have to manage any of the servers or anything like that. It's enterprise level security and it's performance at scale. So we have seen, so just to give you an example, on Prime Day, when DynamoDB is used for search queries within, let's say when you search for a product, right, it has gone up to 5 trillion events per day. Okay, that's absolute crazy number, and this is something which is just for that day, and you know Prime Day goes across 4 or 5 days, right? So that way it's something you can scale to that level. Again, it's something that depends on a single table design, so you need to kind of look back on your applications and see what best can work out, but DynamoDB could be the answer for you. Another thing is it has global replication, which means that, like the way we saw in Aurora, we have one primary for read-write and others only for read, but that's not the case with DynamoDB anymore. You can have multiple reads and writes across the globe, and as soon as you write in one of the table, it'll automatically sync up to a different table within your AWS environment, for example. So that way, you have all of your data globally synced up, regardless of where you read from or where you write to. DynamoDB can do it for you. Now, who else, which customers are using DynamoDB? We have Duolingo. Anyone has used this app to learn something? Yeah, all right, so we know this. Sometimes the owl also annoys, right? Because it gives you multiple notifications. You haven't been learning, right? So in this case, DynamoDB is used by Duolingo, and it has in-memory caching and also transactional data. It's for Aurora. Again, any customers, Netflix? Yes, Netflix uses every day, yeah. So even for Netflix, DynamoDB is a database of choice for ensuring that they are able to have operational resiliency across multiple regions. So that way, let's say you travel, maybe you travel here from a different country, and you still want to watch your favorite Netflix shows, right? So that way, it maintains that in the back end by using the global replication. Going further, DocumentDB, right? Anyone, I think given the fact that we are old here, some of them, you know the XML database, right? So I think XML database was pretty much the precursor for document, right? So now when we look at document or the JSON, right? So we have got a managed service for this one, okay? Now documents are how we kind of naturally map the data, right? So you can have your nested JSON. You can actually have a flexible schema through which you can query your documents. And that is something, again, a managed service for you, because if you are running, let's say, MongoDB clusters, and for those who are MongoDB DBAs, I can empathize with you because it's painful to run or rather manage self-managed cluster. So that way you get the best of both worlds. So you have got MongoDB managed for you, which is called as DocumentDB, and you can run all of your queries, requests, and so on and so forth accordingly. So that way you get enterprise-grade security, performance, while you are still working on your DocumentDB, for example, or your documents per se. We have multiple customers who are leveraging the power of DocumentDB. We have Samsung, Dow Jones, and there are a ton of them. You'll find them mostly on the AWS website. Going further, in memory. How many of you used Redis or Memcached here? Quickly. All right, so we have some people in the team. Fantastic. So now, given that it's so the thing is, I was asking how many of you have used Redis or Memcached here? So I got some quick raise of hands, but thank you. I thought maybe I was not clear in the question. Thank you. All right, so here we have got a managed service. Now, a typical usage pattern is that you want to have some real-time analytics store, or you're building a gaming leaderboard, or you're building some geospatial data wherein you are just looking for coordinates, like the way you book an app, book a cab, for example, on Uber, Bolt, whatever. You need this to be instantly, right? If in case you're stuck somewhere, you just need to get a cab, it has to be done as fast as possible. And that is one of the use cases why it's important to have that caching layer on top of your application or on your database. Now, Elasticache is a service which kind of opens up for you to manage or to get a managed Redis or Memcached cluster. So that way, when you are having applications which are already using Redis, you can move them by default to Elasticache, and then you will be able to run the applications in a much more managed way. So that allows customers to have more durability and availability of the data when they have this as managed, for example. So we have a spectrum of durability, in which you look at ephemeral, which means that it is transient. In case the cluster shuts down and restarts, you will not have the same data again. You have to rebuild the cache, okay? So in case if you have use cases like that, you can go for Memcached, which is Elasticache. And then semi-durable, you have got Redis, and for the most durable, you have got MemoryDB for Redis. Now, what that allows you to do is you can retain or pertain your data even after the cluster restarts, or maybe you don't have to take the time to rebuild the cache because it takes a lot of time for applications to populate that all over again in case there is an infrastructure failure. You definitely don't want that to happen. You can go towards MemoryDB. Again, it's a managed service. It allows you to have much more fast-changing rankings. You can have sub-millisecond data access, and so on and so forth. So this is a typical way of internet scale applications, and if you are looking for memcached, where you just have a caching layer, small in between, but you still want to have instant access or ultra-second latency access, you can go for that. Now, Peloton is one of the customers who do that. Okay. Now they are using this to make sure that they are able to push the respective training links or the programs that people can quickly start working on, and they can just reach the leaderboard. Going further, we have Graph, right? Any Graph database users here in the room? Okay, fantastic. All right. So I'm happy that we have got a very database-centric crowd. So for Graph, I mean, it's a typical use case is to have, you are going to have some kind of connected data set, okay? Which means that you will be able to, let's say, derive a relationship and see what business value can you get out of the relationship. This is pretty common. Let's say you send someone a connection over LinkedIn, and it'll tell you that, okay, these are the probable connections you may know. Similarly, friends you may know on Facebook, something like that. So this is where it becomes all the more easy to run your data, or rather have your data stored in typical Graph database, right? So a quick comparison between these two. We have got tables on the left, in which you pretty much can still run a join query and get the data which is distributed across multiple tables. Here, you don't have to run any kind of join. It depends on the way you design your data. But here we have something called as nodes and vertexes, all right? So that's basically the terminology. So you save your entity or other entity in that specific nodes, and the vertexes and edges are basically more of relationships or the properties about that. So that allows you to store n number of entities, and you can just query your relationship data through them. So for that, we have got Neptune. Now, Neptune is, again, a managed service for built a Graph database for the cloud, and it supports Apache Tinkerpop and W3C RDF graph models, and you can query pretty much billions of relationships in no time. So depending on the way you design your application, you can leverage this in the long run. You have got 6 replicas of your data. Like I said, it's kind of leverages similar architecture, so you have got extremely high data availability. Okay, and if you are using Gremlin or Sparkle, it just works as is. Now, which customers are using this? We have Nike, who are prominently using. So if you have the Nike training app or Nike running app, so that gives you multiple programs and kind of tells you, okay, maybe if you're running, you can do some other sports as well. Maybe you're swimming, you can do something else as well, and that allows customers to be more hooked on to the right exercise or right routine, so on and so forth. So then going further, we have got time series. Now, time stream applications are extremely crucial if you want to kind of maximize the scope of time, okay? Wherein you see certain data points over a spectrum. And that allows you, for example, let's say a typical use case is that you are having a set of farms, and you want to control the temperature. This is a very famous customer who uses similar tech for their farms in Italy to grow the right kind and size of tomatoes, right? So you want to make sure that temperature control, everything else is proper so that you get the best tomatoes all the time, which is fantastic, but again, difficult to do. So to make sure that you are able to have n number of application events, IoT sensor data, and you analyze it, at what time the temperature dropped, so that you can control the respective output of that. All of this is important, and when you go for it, it will be something which is more of extremely time-sensitive data, and you'll be able to have more append-only data lifecycle management. So you can query time over intervals, you can have data collected over a certain period of time, and then analyze trends. So you get certain functions which are in time stream, and you can pretty much run that. So here you can have trillions of daily events, because in a certain time frame, you'll have certain temperature control, weather control, so on and so forth. And there are like n number of factors which come into that. And that allows you to kind of do a trend analysis to see at what time certain things have changed. And this is a managed service which allows you to be more flexible and see what best can work out. So here you have got Autodesk and Grafana Labs. I'm guessing Grafana users are in the group, yeah? All right, fantastic. Okay, everything, exactly. Yeah, you seem to be running everything. So this is great. So yeah, so I mean, it's something that a lot of customers, they want to do kind of drill down on, let's say open telemetry and IoT and things like that. So definitely that's a fantastic use case for those customers. Going further, we have got Ledger. Right? Now, when you say ledger, it basically means that you are wanting to have a complete immutable history of records. So this is useful for banking applications, which allows customers to ensure that they are able to build a ledger. Obviously, it's more like a linked document kind of thing. And in case something changes on the document, you can track who did what. Okay? Currently, we do it on auditing basis on different databases. You use different third-party services as well, or locally, it doesn't matter. But the idea is that if you're wanting to build a ledger and to keep a track of all changes that have happened, and no one can edit them or change them, or no one can delete them. So that ways you can control who does what. So it's something different than blockchain. Blockchain is more for decentralized databases. Okay, here it's something similar, which is meant only for immutable record of data. That's it. Yeah, that's a great question. So, sorry, the question was it based on blockchain? So it's different. Yeah. So you get like multiple factors of risk reduction, data tracking improvements, and so on and so forth. And here, the beauty of this is that it is append-only ledger. Like I said, there are a lot of customers who want to build trust with their partners or with their vendors. Imagine, let's say you want to go and buy a home, you want to see who else has bought this before, who are the previous owners, and no one wants to be ideally dealing with or changing that data, right? Even the government or even the customer. So that ways you need to build that trust publicly, and you can do that with a typical verifiable journal. It has a key feature which is called as cryptographic hashing that allows you to make sure that, okay, let's say you write a certain data point here. So everything that is added onto that, it is cryptographed, it's kind of hashed on top of it so that no one can break the chain. No one can just simply take a certain part out of it and try to decrypt that. So it doesn't work like that. So that way you have a fully secure ledger. We have a BMW who's using this as a service to build what is called as a vehicle passport. Now, what that means is you'll be able to identify who have been owners, is the car serviced properly, is the maintenance fine, or the insurance, everything is fine. So it is your right to know as a customer that this data has not been changed just to sell the cars fast, something like that. That's something that you need to be able to do. All right. So lastly, we have got wide column data. Now, for wide column, so you are able to build low latency applications and you can easily, let's say, for example, if you are any Cassandra users in the group. Cassandra, no, not yet? All right, okay. So this is for those customers who are leveraging Cassandra on premises, but they still want a managed and much more secure service. You can go for, Amazon Key Spaces. Now, Key Spaces is again highly scalable, available, managed Cassandra compatible service, which allows you to have the same drivers and tools that you use on premises to run Cassandra cluster. You can have it as is on a managed service, which is Key Spaces. Okay, and everything else, no servers to manage, millisecond latency, and a great performance is pretty much available. Now, the thing is, you can use like CQL, which is Cassandra query language, and you can have your large applications at scale which are running. Right? So there are tons of customers who have used it. One of the biggest is Intuit, and the QuickBooks platform powered by Intuit. The QuickBooks, there are a number of them. So they are using this to migrate their on-premises to Amazon Key Spaces as a managed service. All right, so you get a good sense of how things are, across the whole family of databases that we have. Okay, so the approach is to architect the services from the ground up and see if they are meant for, they're rather cloud ready. Okay, you have the option to choose and change, right? We get a lot of questions that, okay, can we move from one service to another? Can we move from RDS to Aurora? You can. It's not like you are locked up, right? So that way, it's very easy for the customers to change their mind in case it doesn't work out for them. You can experiment with it. And you can innovate faster through managed services because you focus on your core business and not running on your infrastructure or upgrade or something like that. That allows you to have more focus on the right things. All right, so quick demo time. I'm going to show you a quick demo. By the way, this is the architecture right now, which means that we have got one primary. It's an EU West one, which is in London region, and we have got secondary. Okay, so I've created a global database that will allow us to have whatever we write in the primary will be available in less than a few milliseconds in the secondary, which is US East one, and also AP Southeast. All right. So as soon as you write something in London region, it's going to be propagated within a matter of few milliseconds across the globe. But then, let's say due to some reason there's a challenge, there's a failover, and you actually want to force a failover. So after failover, you can failover it to the different region, which is, let's say, US East one, and that can be the global endpoint. Okay. By the way, this is something which can also be automated. So you can have a single endpoint in which, in case something fails in London region and you still want to be able to do that, you can do that. Yes, you have a question.
I can see from this picture that is the Australia data center will be replicated from the London one or from the new primary?
It will be. Oh yeah, that's a good catch. So it will be from the new primary. It's my mistake. Yeah, I should have I should have done it from the primary one. Good catch. Yeah. So definitely yes. So the question was, will it be will the Sydney region replicated from the primary or the secondary? It indeed is from primary. It's just different mapping which I did by mistake. So apologies for that. So here. This is the demo. I hope you can see it well. So let me walk you through. So this is the London writer. Okay, this is currently writer instance. And if you look at this, this is the endpoint, which is the application endpoint, right? You can map it to that. And then we have reader instance, which is in US East one. Okay, so we have that mapped up there. And I'm using HammerDB to just do a performance benchmarking, right? Because you can run multiple workloads on that. So here, we can just check that, okay, this is the respective count on both sides exactly the same, something like 8 million, right? And even on this one, let's say we take a look at the North Virginia, which is US East, it's also the same one, right? Now we go back and we start the load. So it's running. And within a matter of few seconds, you'll see the load is increasing in multiples. Right? So that allows customers to kind of keep running extremely high data loads. And as you can see, the number is now increasing. It's now going by few hundred, few thousand, so on and so forth. Okay? So we are running this across both the respective endpoints, and we are seeing that, okay, this is running great. And it is able to sync up within a matter of few milliseconds. To verify that, we also go to this service, which is called as CloudWatch. That allows me to see what's happening in the backend. Okay, so we'll take a look. So you can see here, I'm looking at the global RPO lag, and as you can see, it is still on the left side, it's still very less milliseconds, and you are able to have the data replicated across both the regions, right? Which is in US Southeast 1 as well as the US as well. Right? So this is the one where you can just kind of go more drill down on what's happening behind the query. Okay? So going further, we have a feature called as Performance Insights that kind of helps you go all the more drill down on the query to see what is the CPU, what is the IO, how much is it consuming, on what endpoint, and so on and so forth. Okay? So this allows the customers to kind of see what is the impact of the query on the hardware, right? So that's that. Okay, now we'll see that, okay, currently we'll just now do a quick stop, okay. We have stopped the data load, and before we do a failover, okay, so I can see I can choose that, okay, failover to North Virginia, all right, so it'll change it to this one. And before we do that, I'm gonna do a quick check on, as you can see, it's now 9 million, the number of row count. So I can see on both the endpoints, it is pretty much matching, okay. Now I'll do a quick failover, all right? So we'll just wait a few seconds to do that. And now, as you can see, the writer instance is in US East 1B. So that has become the primary, and the London London writer, which was initially the writer, it has now become the reader instance, okay? And this is something that you can just do it, for example, manually, or you can also build. So as you can see, after failover, this is something which has pretty much happened, and yeah, that's it. So I'll pause this demo for now, and that's pretty much it. So that way, we are able to see that, okay, from primary London region, we are able to fail over to US East 1 as North Virginia, and we were able to achieve this part, okay? So we were able to get the respective records across the globe within a matter of few milliseconds. All right, so like I promised, quick quiz time in the interest of time, right? So I hope you are paying attention throughout. And I'm going to ask you quick questions. So maybe this is a good time to also enable it on the poll.
I have a question about that.
Sure.
If you want to see results of the question, could you go on the Gmail, go on your...
All right, just a second. All right. Okay, so I'm here. Okay. So you want me to show one by one, right? Yes. Okay. Okay. All right. So this is the first question. Okay, I'm going to accept all cookies, and I hope you can see. So the first question is: customer wants to use a database with cross-region replication, which allows to concurrently write and read across multiple regions. Which one do you think it could be? I'm going to give you like... First one. All right. First one? Okay. So that is, let's see. I also got this here. First one. Let's see. Fantastic. Good job. Okay, perfect. Now going to the next one, which is, let me just see. I'm going to bring it up from the poll. All right. Oh. All right. Sorry, just a second. This is, we are just making sure that we are including the, oh, sorry. Okay. All right, seems like people on the virtual end are already answering, which is fantastic. So the next question is, customer wants to build a fraud detection systems and recommendation engine for their banking products. Which one do you think will be the one? Mm-hmm. Yeah. All right. Were you able to cheat it from the from the? Okay, you got it. Oh, fantastic. You are using the poll, which is great, which is great. Are you able to see all the questions at once?
No, just the second one.
This is the second one. Okay, so I need to click that, I think. Yeah, okay, fantastic, okay. All right, so let's go to the third one then, which is open now. Take a look, okay. And I'll also show this here. Oh, it's not yet on the poll. I have opened it. Okay, so take a look. Customer wants to run spiky workloads with relational database with potentially idle periods of time. Which one do you think it could be? So we have got, all right, seems like we have, fantastic, okay, that's great, all right. Let me go to the fourth question. Customer wants to have an immutable system of records for their business transactions. Which database service do you think could be the right one for this? All right, some of them are confused. Time stream, maybe QLDB, maybe we are seeing the numbers as we go. Fantastic, okay. All right. Okay, fantastic. I think we are still having a good mix. Oh, my apologies for the virtual listeners. Maybe if it's too fast for you, don't worry, I'll show you the right answer. But the right answer for this one is QLDB, which is Quantum Ledger Database. All right, last question then. Let's have a look. Customer wants to have fast, scalable, and serverless service to store and analyze trillions of events per day for IoT and other operational applications. What do you think could be the right one? All right, I'm just going to wait and see if anyone else has. All right, some of you think DynamoDB could be a good choice, okay. All right. Oh, you're able to change it, which is nice. Okay. So yeah, for now, I saw that some of you are like thinking, okay, maybe I should just go back to time stream. Fantastic. The whole goal is learning, folks. So that's great. All right. I kept one. So this is the one. Sorry. I kept one as a bonus question. Okay. All right, so this is the last one. All right, so this is not on the polls, but I'm just curious. It's just more of an open-ended question, just to see if you get this one right. And if someone gets this one right, I'm going to give them a gift. Sorry, I don't want to, I'm just being more inclusive of the virtual listeners as well, but just be mindful of that. But take a guess. So customer wants to stream data changes from multiple applications into a single database. Which database service do you think could be the right one?
That depends on, does he want to just like stream the timestamps so this data was changed, or the data itself, because that would be a documented data, the schema-less. Or if you just like timestamps, that would be like a timescale DB.
Right. It could be, yeah. So the answer was it depends on multiple factors. It could be time scale, it could be Dynamo, it could be something else. All right. Actually, the answer is it depends. All right, so that's pretty much it. Thank you so much. Please take the time. We have got multiple free training and certification links available. You can just go to, just type AWS database training and you'll find tons of links. It's a great free resource. You can just sign up and listen to that. And just one small request, please fill in the session survey that allows us to keep the sessions of extremely high quality. Please be kind as well. So in case there is anything you need to share, please do share that on the feedback. Okay. I can wait for a further Q&A, but maybe in person. I'll be here. So please reach out. But yeah, that way I just want to be mindful of time because I know we have more sessions coming up. Right. So I hope you liked it. All right. Thank you. Thank you.